we discussed the fetch execution cycle last day. So before moving to fetch execution cycle, we discussed registers are there. So registers are the volatile memory. It is situated in the central processing unit, and the size of register is less than 64 bits in size. It is the fastest memory. It helps CPU to work faster. So then we discussed register is the fastest memory used to accept or store, transfer, and transfer data and instruction that are being used immediately by the CPU. So whatever the data passes to the computer should go to the RAM, then it is moving to the processing unit. Then it consists central processing unit. It consists of CPU. It consists of control unit, memory unit, and the arithmetic and logic unit. So normally processing part is done with the help of arithmetic and logic unit. It consists of the registers. So registers are the one which temporarily hold the data while the execution is going on. A register can also considered as a group of flip-flop, which each flip-flop capable of storing one bit of information. So later you will study what are the flip-flops. It's there in our chapter 4. Okay, so this is very important diagram in the fetch execution cycle. Actually, we first input data through the random access memory. Main memory means random access memory. Data and instruction, everything. All those things move to the control units. So we call sending data or instructions to the ALU, that may the CPU, as fetching. So sending data to the CPU as fetching. So CPU consists of control unit and ALU. It's moving to the control unit. So inside the control unit, decoding instruction is there. So fetch execution is running in the control unit. Then after that, the registers hold the data temporarily. So those data sent for the data and instructions sent for the execution. So while executing data, there will be some chance to store the data temporarily until complete the execution cycle. So temporary data store in the registers, and next execution keep on. For example, I took adding 0 to 5 numbers one by one. So that time temporary we had to store these values. So registers are the place where we can store the data while going on the execution. So when the execution's over and when we come to the exact ending, then the output will pass to the main memory. So from the main memory, output will pass to the output devices. So this is the main fetch and execution cycle which we use, this diagram we used in the all syllabus. But now new syllabus we have this diagram. But all those diagrams, that means this diagram is mainly based on the previous diagram. So you should have the basic idea of the previous diagram. So the diagram, this one, execution. So before execution, you know, it is starting from the fetch. Why? From the random access memory. Okay. From the RAM, data passes to the control unit. So the starting point should be in the fetch. First step should be in the fetch in this diagram. Here, number 1 should be there. Okay, fetch. Then decode. Fetch is done in fetch execution is happening in the control unit. Then decode instructions also happening in the control unit. That is number 2 I'll take. Then it should be the order. Then execution is happening inside the ALU, number 3. Okay, so steps decode instructions into the command. That means when we consider this one, step 1, fetch instruction to the control unit. Then inside the control unit, decode instructions into the command. So given instructions converted into the commands. Then step 3, executes the command. Step 4, store the result in main memory. After completing that, store the result in the random access memory. So this is the fetch execution cycle. So if you get a question and ask you to draw, so you have to draw both together. It's very clear. So normally that depend on the question. Okay, stages, if they ask, then the first one. And if they ask to draw in detail, so this, that. Okay, so fetch cycle is happening in the control unit, then decode is also control unit, and execution is happening in the ALU. Okay, so then we are going to discuss what are the things happening there, how fetch and execution cycles support the one human architecture. So fetch execution cycle explain how data is processed with the help of control unit, ALU, registers, and random access memory. So as we discussed earlier, there are three cycles such as fetch cycle, decode cycle, and execution cycle. So fetch cycle, decode cycle happen in the control unit. Then execution cycle happen in the ALU. So fetch and decode we can take here. Better write and. Then as von Neumann explained this in his architecture, he uses a single processor which follows the linear sequential fetch, decode, execute. So fetch execution cycle had in single processor at that time. So John von Neumann introduced the idea to store program that time. So today we are using registers to store the program and instruction. Okay, so up to this section we have discussed in the last day. In fetch and execution cycle, there are mainly three stages. Okay, so fetch instructions, decode instructions, and execute instruction. So that's what here explain the fetch and execute cycle. There are three steps in fetch execution cycle: fetch instruction, decode instruction, execute instruction. Then fetch instruction to the control unit from the main memory, random access memory. Decode the instructions into commands in control unit. Example, counter, increment the program. Lastly, we discussed we can do some calculation part. Then that means decoding is also happening inside the control unit. Okay, so fetch instruction to the control unit from the random access memory. So fetch cycle is happening inside the control unit, and decode instructions into command in control unit. Then execute commands inside ALU. So execute cycle happen in ALU. Registers are used in decode instruction and execution instruction. So here another earlier we discussed fetch cycle and the decode cycle both happening inside the control unit. Okay, so registers are used in decode instruction and execute instruction. So executed result in main memory, random access memory. All process command has to complete fetch instruction, decode instruction, and execute instruction steps in fetch cycle. Okay, then next point was there in the other one. That means this slide. Okay, so fetch and execute cycles are happening inside the control unit. That point I will take it there from here. After this, copy down these last 2 points. Fetch, execute, decode instructions. Fetch and decode cycles happen in control unit. Then execution cycle happens in arithmetic and logic unit. Okay. What are the registers used in fetch decode execution cycle in the von Neumann architecture? So program counter is the register, and memory address, the highlighted ones are most important. Current instruction registers also there, but memory address registers, then memory data registers, and accumulator. So accumulator is the most important one. It is inside the arithmetic and logic unit. First, we'll copy this one. These registers are used to store the data temporarily. Here, it's remained inside the register. That means this location. So the examples of these registers are the ones which I explained now. Copy down this one. So just look at, this is the process what we have to do. X is equal to 1. X is equal to 1. Then total is equal to 0. For loop is there. X equal to 1. Then up to X is equal to 5. Find the total. Print X. X equal to 1. X plus 1. Then print the total. So this should execute until the total becoming X is becoming 5. So here, starting X is equal 1, the total 0. Is X lesser than 5? Yes. Then X is equal 0 plus 1 equal 1. Print X. Then X is equal to X plus 1. Then it becoming 2. So that 2 is going here. Then X total is 1. Then you will get, is X lesser than 5? Yes. Then 1 plus 2. So likewise, you will increment up to 3. Then the third iteration also going on. Then fourth iteration. While going on, when it comes to 6, it is not going to add there. So fifth one, just look at 10 equals 550. Then increment 1 to the X, it's becoming 6. So 6 is not lesser than or equal to 5. Therefore, print the 15. So at that moment, we have to store the data in the register. So these values has to be saved in somewhere. So that location is the register. So register temporarily store these values, but output will give the final answer. So this blue color one, I indicated the decode instruction. If a blue color one, initializing into command and decode instruction. Then arithmetic and logic unit does the function, that is green color. Okay. So then final output coming to the random access memory. So this is just to know, no need to write. Okay, fetch execute cycle begins as soon as the power is introduced to the system. So when we switch on the computer, then fetch execution cycle is ready to start. That means ready to do some process. Fetch execute cycle is very basic way how computer is processed. So it explains how the computer is processing. So basic step. Building block of the computer is the fetch execution cycle. All commands are executed through the running of fetch execution cycle. So all the commands, whatever the process is going on, it has to be go through the fetch execution cycle. Okay, we'll copy down this one also. The previous one, no need, that just to understand I gave it. Okay, copy this one. How fetch and execution cycle supports one human architecture. So, fetch and execution cycle explains how data is processed with the help of control unit, ALU, and the random access memory. So, the fetch and execution cycle consists of 3 cycles: fetch cycle, decode cycle. So, as von Neumann explained in his architecture, he uses a single processor with the follows the it consists of linear sequence fetch, decode, execution. John von Neumann introduced this idea to store programs that time. Today we are using the registers instead of that. So I explained this one earlier also. So we'll copy down. There can be a question from this one. Explain it with the von Neumann architecture. Okay. Copy down this one.